Okay, next one, Norton's theorem. So first look at the statement. Any two-terminal active network containing voltage source and resistances viewed from its output terminals. So let us take, this is a network, we can see it from two terminals. Okay, viewed from terminals, it is equivalent to constant current source parallel resistance. It is equivalent to constant current source parallel with resistance. The constant current source equivalent to the current which would flow in the short circuit placed across the terminals, and the parallel resistance is a resistance of a network when viewed from the open circuit terminals. After all, this is important, after all voltage sources, current sources have been removed and replaced their internal resistances. This is a network Thevenin's theorem statement. So according to the statement, look at here, we have a network with voltage sources. The first case we are find out in the short circuit current, that is ISC, and then open circuit these two terminals we can see from here, that is a RN, can connected RN or RI here mentioned, parallel to the circuit, parallel to the current source. This is a equivalent Norton's network. In the examination, in our mock test examinations, in our mobile app we have a test series. Those are taking the KVS TGT course, W Work Experience Teacher. Each and every chapter I am providing the test series. In the test series, this type of questions, in the final exam also this type of questions will be appear. In case of Norton's theorem, below statement is correct. The question is like current source parallel with resistance. They also mention ideal current source or constant current source is parallel with resistance. That is a correct option. Remaining options like that, current source series with the resistance, current voltage source series with the resistance, voltage source parallel with the resistance. Which option is correct? First one, current source parallel with resistance. Okay, this is what Norton's theorem. I will explain this total entire this theorem with the help of the example. Okay, what is the statement here? If you are taking, okay, let me take this as an example. So here in the statement, the voltage and resistance viewed from the output terminals. So this particular network, find out the equivalent Thevenin's network, you need to do that. Equivalent Norton's network you need to find out. So for that, the first one, voltage sources, the first step is to find out the RN, Norton's resistance. How to find out the Norton's resistance? All voltage sources and current sources are replaced by the internal resistance. Any internal resistance is mentioned here? No. That's why voltage source should be short circuited. If current source is there, open circuited whenever there is no internal resistance. If internal resistance is there, we can replace their internal resistances according to the statement. Okay, fine. So the first step is to find out the RN. We viewed from these two terminals, short circuit the voltage source. So 4 ohms and 12 ohms are connected in parallel. So whenever 4 ohms or 12 ohms connected in parallel, Rn is equal to 4 into 12 divided by 4 plus 12. That may be equivalent to 48 divided by 16, that is 3 ohms. What is the Rn value? 3 ohms. Everyone got the idea about the how to find out the Rn. Rn is same as Thevenin's resistance, procedure is same. In case of maximum power transfer theorem also, the same procedure to find out the internal resistance. Source resistance is equal to load resistance in that case. Okay, clear? Next we are moving to the step 2. What about the steps 2? According to the statement, you need to calculate the short circuit current. See here. The constant current is equivalent to the current which viewed from the short circuit placed across the terminals. So these two terminals, I am going to short circuit it here. Okay, whenever I short circuit these two terminals, this short circuit current is known as IN. Okay, so I will find out that short circuit current IN, or short circuit current, sometimes ISC also you can call it as a. So whenever this short circuit resistance is 0, there is no resistance in between the A and B terminal, short circuit resistance 0. 0 parallel with any resistance, it make it to 0. See here, I will make you calculations here. 0 into 12 ohms, parallel connection, right? Both are parallel. 0 plus 12, what is the value? 0 ohms only. So this particular 12 ohms is neglected. Okay, only 4 ohms is there. Directly we can calculate IN is equal to 24 divided by 4, that is equal to 6 amperes. I got IN value also. Once I got IN value, step 3, equivalent circuit. So here equivalent circuit. The equivalent circuit is IN, that is a 6 amperes, and RN 3 ohms. This is the equivalent circuit. In case, for example, we have some load resistance is there. Let me take 1 ohm is the load resistance. So whenever load resistance is there, you can calculate the current. The formula is IN into RN divided by RN plus RL. This is the formula to find out the load current. That is a 6 into RN value is a 3 ohms divided by RN plus RL. That is a 3 plus 1, that is a 4. Here 3 times 2 times 9 by 2 amperes, that is equal to 4.5 amperes. That is a load current. This is the procedure to find out the load current using Norton's theorem. I hope that everyone is enjoy the class. We are continue further with help of the next example. Using Norton's theorem, calculate the current flowing through 12 ohm resistance. Okay, right. In the step 1, calculate the RN value. How to calculate the RN value? Short circuit the voltage source if there is no internal resistance, and it is a 6 ohm as well as 3 ohm and 4 ohms. This A and this B open circuited. This is a RN. Now these two are connected in parallel. So R equivalent 1 is equal to 3 into 6 by 3 plus 6, that is equal to 18 divided by 9. It is a 2 ohms. This 2 ohm series with 4 ohm. So finally Rn is equal to 2 plus 4, that will be equivalent to 6 ohms. So I got Rn value in the step 1. Next we are moving to the R2 case. Step 2. The step 2 IN value or short circuit current, IN value or short circuit current. Let me draw the diagram for in the second case, second step. Make you this 36 voltage source should be there. There is a 3 ohm, 6 ohm, 4 ohm, and a short circuit these two terminals. Okay, this current is a IN short, that is a Norton's current. So you want to calculate this current, we can use any method. I will use Ohm's law. IN is equal to, I am using current division rule. The current I, total current into, you want current flowing through the 4 ohm, opposite resistance 6 divided by 4 plus 6. So I want this current, right? I want that current, that's why I is equal to V by R equivalent. I want to find out the R equivalent first. R equivalent is equal to, these two are connected in parallel, series, parallel, 4 into 6 by 4 plus 6, that is equal to 24 by 10, that is a 2.4 ohms. Okay, so once that is a 2.4 ohm, that is series with the 3 ohms. So therefore R equivalent, final R equivalent is equal to 3 plus 2.4, that will be equivalent to 7.4 ohms. So I got 7.4 ohms is a resistance. Once I got 7.4 ohms, V is a 36 divided by 7.4. That will be equivalent to, okay, here small correction. It is not 7.4, 5.4. 3.36 by 5.4 is equal to 6.66 ohms. So, amperes. So, finally, IN is equal to 6.66 into, 6 divided by 10. 6 divided by 10, that is equal to 4 amperes. So, I got 4 amperes is a Norton's current or short circuit current. Once you got Norton's or short circuit current, in the step 3, find out the load current. To find out the load current, the equivalent circuit is voltage source, that is a VT IA. So here IN value is 4 amperes, in series is 6 ohms. Finally, IL is equal to IN into RN divided by Rn plus RL. This is the formula. So same as current division rule. Simply current division rule is total current into opposite resistance, that is Rn divided by Rn plus Rn. That is equal to 4 into Rn value is a 6 by 6 plus 12. That is equal to 4 into 6 by 18. Here 3 2 times, here 3 6 times, here 2 times, 3 times, 4 by 3 amperes. The current is 4 by 3 amperes, that will be equivalent to 1.33 amperes. That is the load current. So I hope that you got clear idea about the. Next we are moving to the example 4.6. In this example, using Norton's theorem, find the current through 6 ohm resistance. We have a 2 sources, 60 voltage and 12 ampere current source. Okay. In case of objective examination, in case of KVS examination, examination is objective. We can follow any one method to find out the current. But in this case, I am going to explain with the help of the Norton's theorem. Okay, it is very simple. Just look at the problem. You need to find out current here. In case of Norton's theorem, we have to find out the 2 components. The first component is RL. So just find out the RL component. It is easy. Short circuit the current sources to find out the RL. To find out the RN, Norton's current, Norton's resistance. This is a 20 ohm. This is a 6 ohm. That resistance should be open circuit. In case while you are finding out the RN, it should be open circuit. And this is a 5 ohms. Current source should be open circuited. Okay, the resistance between these 2 terminals is nothing but a Rn, right? So Rn is equal to this is a, we can see in from here, these 2 are connected in parallel. 20 into 5 by 20 plus 5, that is equal to 100 by 25. It is equal to 4 ohms. For your understanding purpose, explain slowly. In the examination, you can speed up the calculations. Next, Rn. After that, Rn, IN, Norton's current. That is the second point you need to do that. In case of Norton's current, to find out the Norton's current, this is the procedure. So, you need to present voltage sources, right? This resistance should be short circuited. This is a 5 ohm resistance. This is a 12 ampere. Okay, this is the circuit we have. But you need to understand carefully. You need to find out the current, this short circuit, that is a Norton's current. whenever short circuit connected parallel to any resistance, maybe 1000 ohms or 1 lakh ohm, any value of resistance you are connected in between across the short circuit path, that resistance going to be 0, right? I will prove that here. R equivalent, in this case, this is the resistance here, 0 resistance, right? Here resistance is 5, 0 into 5 by 0 plus 5, R1 into R2 by R1 plus 5, that it will be equivalent to 0 ohms, right? That's why it is negative. Only short circuit part is present. Just move to here. Now what amount of current 12 amperes is flowing through this portion, that is a 12 amperes. There is no other path. Okay. Next, coming to here this particular portion, what about the current will be calculated V by R, that will be equivalent to 3 amperes. These are both the currents will be flowing here. That current will be 3 plus 12, it is equal to 15 amperes. We can write it here, 3 plus 12, it is equal to 15 amperes. So I got Norton's current also. You want load current IL. So to find out the load current IL, the formula is Norton's current into Rn divided by Rn plus RL. 15 into Rn value is a 4 ohms, right? Here 4 plus RL is equal to 6. That will be 15 into 4 by 10. This is the 3 times, this is a 2 times, 1 time, 2 times. That will be equivalent to 6 amperes. This is about the solution. In the examination, they are asking about the load current. What is the load current? 6 amperes is the load current. Okay.